Well, welcome. In this video, we're going to be using what we've learned about in this chapter about non-right triangles and navigation problems and put those together into these different application problems. So let's look at this example. Here we go. It says a fisherman leaves his home port and heads in the direction north 70 degrees west. By the way, we're going to change that to bearings, or we would also be given that in bearings if it were the test. But anyhow, he travels 30 miles and reaches Easter Island. The next day, he sails north 10 degrees east for 50 miles, reaching Forest Island. Talk about these navigation pieces. When they give you, again, north 70 degrees west, or another way to look at it would be 70 degrees west of north. On the test, like I said, we will give you both that type of navigation as well as bearings. So I just want you to see what this value would be. So 70 degrees so going north and then 70 degrees west would be like this. So this angle here would be 70 degrees. Another way to look at it would be to say a bearing of 290 degrees. Because a bearing of 290 degrees would be the same thing. The only reason why sometimes this other way, saying 70 degrees north, 70 degrees west, or 70 degrees west of north is a little bit easier, is then when we go to do our drawing, we don't have as big of an angle that we're looking at, so it's a little less confusing. Or if they do give you the bearing of 290 degrees, you can always subtract it from 360 to figure out that this angle here would be 70 degrees. All right, so let's start with our diagram. So I'm going to start down here. Since we're going in that kind of up and to the left direction, we're going to start towards the bottom there. So we'll call that so that's where he's starting from. So that's like his home port. So call that H. And again, 70 degrees would be that angle there. All right, and then it says that he travels 30 miles. We'll say this is 30 miles, and he reaches Easter Island. So we'll call this E for Easter Island. The next day he sails north 10 degrees east. Okay, so that would be, so another way to look at that is that would be the same as saying a bearing of 10 degrees, because east by 10 degrees would be the same as a bearing of 10 degrees. So again, don't have to worry about that on the test. We will give this to you in terms of bearings. So this little angle there is 10 degrees and travels 50 miles, reaching Forest Island. So there's Forest Island. All right, so the question, actually I shouldn't have drawn it on this page, get to do it over here, is find the distance between the fisherman's home and Forest Island. So I'm going to draw that diagram right here. I'll redraw it here so we have, whoops. Okay, so again, this was 70 degrees. Just bear with me for a second while I do this. And this tiny angle there is 10 degrees. Oops, that's 50 miles. And there's forest. All right, so what we're trying to figure out is we're trying to figure out that distance. So this is not a right triangle, and I can verify that in just a second, but this is not a right triangle. So we can't always assume that it is. We always have to determine if it is or if it isn't. Okay, so let's see what we know. All right, so I know that this angle here is 80 degrees because my north and east would make a right angle. And so if that angle here is 10 degrees, that means this angle that's made to the east and that angle there would be 80 degrees. So now I got to figure out, well, what's this angle? Well, remember, this angle here is going to be the same as this angle here. And if we know that this one is 70 degrees, that means this one here is 20 degrees. So that means this is also 20 degrees. So what that means, I'm going to erase that. Let's just do this. I'm going to erase that interior. 80 plus 20 is 100. So we just found that angle to be 100 degrees. So that is not a right triangle. So now we have a side angle side situation. So if it's side angle side, we can use a law of cosines. So it would be x squared equals the two sides being squared added together minus 2 times those same two sides, 30 and 50, times the cosine of the included angle, the 100 degrees. And when you do that on your calculator, we get 3,921. Take the square root of that, and we get 62.6 miles. The answer. Okay, now the second part, it says find the bearing from his home port to Forest Island. Okay, so let's go back. All right, so we want to find the bearing here that I had already pre-done here in green, and I also fixed this. This is supposed to be the home port H, not F, but that's the bearing that we're trying to figure out. Well, in order to do that, we need to figure out, because we know that this is going to be 270. Let me erase that actually. So this is going to be 270. We know this angle here is 20 degrees. So what I need to figure out is this angle. So I can add that to my 270 plus 20. So I can add that to my 290 degrees. So if I can figure out that angle, that will give me the angle I need to find the bearing. Now remember, with the law of cosines, once we start with the law of cosines, we have to finish with law of cosines. So we have to use the law of cosines to find that angle. So I'm going to go back to this slide to make it a little easier. But recognize that this side is the one that's across from that angle. And we know this side over here to be 62.6 miles. So we can use that information. So we can use this as a side-side-side scenario to find the missing angle in between here. So I'm going to do my work over here on the other slide, but again, we're going to start with the side opposite the angle that we're trying to find. So we're going to start with that side that's 50. So I'm going to say 50 squared equals the other two sides squared and added together. So 30 squared plus 62.6 squared minus 2 times each of those sides. Oops. Times the cosine of the angle, which I'll just say cosine of angle H. Now remember, we have to keep these separate. So what I'm going to do is I'm going to subtract from both sides of 30 squared and 62.6 squared. So I'm going to do that piece first, and then that's going to equal, and then I'll multiply these together. All right. So when you do that, this answer over here on the left side will be negative 2,318.76 equals, and this over here will end up being negative 3,756 times the cosine of h. So if we divide both sides by negative 3,756, we get that the cosine of h equals this decimal, 0.6173. Then remember, we take the inverse cosine of that. And so that little angle there, angle H, will end up being 52 degrees. Remember, we're going to use that. I'm going to go back a slide. We're going to use that to find the bearings. Let's think about what we know here. So now, erase some of this information to make it a little easier. For some reason, it's not erasing, but just know that this is 52 degrees, this angle right here. So we know that this angle here is 20, and that this is 270. So the bearing, I'll just do it on this slide. The bearing, we would have the 270 degrees. Whoops. Okay, that's the 180 plus another 90 would be 270 degrees. Plus that 20-degree angle, which we found out earlier, plus the 52 degrees that we just found out, gives us a total of 342 degrees. So that's what your bearing should be for this one. All right. There's one last example here. If you'd like to try this one on your own, you can. It says a ship leaves port at 1 p.m. traveling north at the speed of 30 miles per hour. At 3 p.m., the ship adjusts its course to be 20 north, 20 degrees east. How far is the ship from the port at 4 p.m.? All right, so I'll help you come up with a diagram here. Now, so when it leaves port, it's traveling due north at a speed of 30 miles per hour. Okay, so from 1 p.m. to 3 p.m., that's 2 hours. So distance, remember, is rate times time. So 30 times 2 would be 60 miles. Okay, so again, I got that because the rate was 30 miles per hour for 2 hours. So 30 times 2 would be 60 miles is how far they traveled. And then it changes its course, so just do C for change, to be north 20 degrees east. So again, what that means is that's 20 degrees east of north, or we could just say a bearing of 20 degrees. If that confuses you, again, don't worry. On the test, we'll give you the bearing always, so that way it can make it simpler. And that's from 3 to 4. So that's for 1 hour. It travels the same speed, so this would be 30 miles. So our goal is to figure out that distance. That's what we're trying to find out. So in order to do that, oh, and I forgot to get this. This is 20 degrees. So that little angle there is 20 degrees. And so what we need to do is we need to figure out this angle, which we can put together. I'll have you guys see if you can't figure that out on your own though. And then once you have that angle, then you don't have to find the bearing for this one. You just need to find the distance. So I'll give you guys a minute to go ahead and see if you can't figure that out. So pause the video and hit play when you're ready to check your answer. All right, so what you're going to do is you get 88.8 miles. The way that you get that, though, is, again, that angle C there, that included angle, that's 160 degrees. And the way that we get that is we know that between the north and east here, we have that angle there is a right angle. And then this angle here would be 70 degrees because the bearing was 20, so 70 plus 90 would be 160. And then you just piece it all together using your law of cosines. Do the math and you get 88.8 miles. All right, well that's it. So I'm going to have you guys do any 4 of the 7 problems in your packet. So in your homework packet for lesson 5, there are 7 application problems like these that are not right triangles. And so you can choose any 4 of those 7s to do. So good luck as you work on your assignment.